I'm just going to cover a few things in this talk. First off, how we're using Elasticsearch, what we're using it for. Stuff we've done might not make sense if you're using it for different things. The architecture of our Elasticsearch cluster over time. It's come a long way over the last 2 years. And then a little bit about observing your cluster itself, how you can monitor it effectively and get the most out of it to identify the problems you're facing. So for anyone who's not used Elasticsearch before, it's this. It's a distributed document store, and it's got a massive massive list of use cases. So people use that out there for front-end search, machine learning, centralized log platforms, and everything in between. So what do we at AutoTrader use it for? So hopefully you've heard of AutoTrader, but if you haven't, we're the UK's largest digital marketplace, which isn't the most glamorous title, but we hold it proudly. And we were looking at Elasticsearch about 2 years ago for two key reasons. As we moved towards a more microservices-driven architecture, and as our infrastructure became more and more ephemeral, we realized there was a growing need to have a centralized logging platform to give developers insights into how their applications are performing. And we also wanted to build a metrics platform that allowed development teams to run experiments and get really fast feedback and really good insights into their applications. So if I make a button blue, do I get a better user response? And we needed a platform that would provide rich insight into that with really rich metadata for events, rather than some of the traditional time series databases, which just give you a value and a metric. We needed value metric and a whole load of metadata to go with it. So those were our two main reasons to build Elasticsearch, and we did so about a year and a half ago. We started with two main things in mind. We wanted to make it really, really easy to use. We didn't want the developer to have to worry about how they're going to send logs, where they need to send them to, how they instrument their code. We'll give them simple libraries that they can drop in and get it out of the box. And we also didn't want to impose any hard limits on users. So I've been to a few talks of people using Elasticsearch, and they say, it's great, but we restrict what people can do in order to keep it a sane data volume. We didn't want to do that. We wanted to just say, do what you want with it. If it's a problem, we'll come speak to you, but if not, you can run wild, that's fine. And with those two things in mind, we got a really good uptake when we built it. So after a few months, we were indexing about 20,000 documents a second, which doesn't sound like loads, but at the end of the course of a day, that's about 1 billion documents, and that needs quite a lot of hardware to run. And because of this, we've faced quite a few issues. So I want to talk about a few of the things that we've faced as we've come along the journey, things we did, where we made mistakes, where we failed, and then what we've done to try and rectify and improve that. So architecture-wise, this is what we started out with. Fairly standard Elasticsearch architecture, quite a few moving pieces, and this is what we went and built out from the off. It's sort of a very standard approach, and it's what people would recommend. And we had a lot of issues with this. Stuff was going in one side, and then never coming out to the other end in Elasticsearch. We had a rabbit queue, which, for anyone who doesn't know, rabbit is a messaging queue that gives you persistence, except it did the opposite for us. We found that it kept dying and causing issues. So we had this cluster with about 5 moving parts. We were all really new to Elasticsearch, all really new to rabbit fairly as well, and it really wasn't doing its job. So we took a step back and said, how can we simplify things? How can we make it easier to diagnose these issues? And following the KISS methodology, which it's keep it simple, stupid, we followed that. So we decided to rip out the bits that weren't working for us and focus on the core of the stack. If we can focus on the throughput of stuff going in one end and making sure it gets to the other end, and then we can improve the resiliency over time. And that was really good for us. Gave us a bit of breathing room for us to actually dig into Elasticsearch and learn a bit more about how it runs. And the biggest thing we faced, which we faced for about a year and a half as we developed it, is Elasticsearch is very disk hungry, and that pained us quite a lot. So, that was a lot of slides. So Elasticsearch is quite I/O intensive. It requires a lot of disk, and we had sort of, I guess, not the hardware we wanted. So we had to take some pragmatic approaches to improve things. And one of the things Elasticsearch does, and it does really well, is it does a lot to keep your data secure, stored, persisted, so you don't lose any data, and that's really good. It does this largely through a transaction log, so if anything hasn't been persisted to the underlying storage engine and a node dies, you've got a transaction log which it replays from, which is really good. But ultimately, that is a lot of disk when it's writing that transaction log on every single insert, update, delete operation. So with Elasticsearch, you can disable this and say, instead of doing this on every single operation, let's just do it every 5 seconds, every 10 seconds. It does mean you introduce some risk about your documents. You risk if you lose a node, you might lose 5 seconds of data. When you're running a metrics platform with billions of documents a day, 5 seconds of data isn't too bad to lose. It's nothing critical. It's nothing. None of that information is vital, and it's worth it for the trade-off in our case to make these changes and accept that risk. And when we make this change to the durability, we found our I/O usage on our cluster went from about 75% to 25%. So really big savings for really small bits of config. And then the other thing is a refresh interval, which is another quite intensive operation that controls how often your documents become searchable. I think the default is 1 second. But in reality, do you need to see everything every second? Probably not. If you're only human, you're probably looking at past data or recent data, but whether that's from 1 second ago or 5 seconds ago or 30 seconds ago probably doesn't matter too much to you. So we implemented that as another feature, and this was another massive win. There's a link there for a benchmarking blog that someone from Semitex did, and by increasing that refresh interval from 1 second to 5 seconds, you can increase your ingest throughput by about 25%, which is just, in our books, is a really good win to go for. If you're doing real-time analysis of this data, you might not want this, but for human consumption, between 1 second and 5 seconds and 30 seconds, not a whole big difference. So that gave us a lot of legroom over the past. That gave us a lot of legroom for about 6 months. But as we started putting more and more and more on the platform, it got more and more under pressure. And as it got more and more under pressure, less people were using it. And if no one's using a platform that we solely intended for people to use, then it's a bit of a failure. So we took another step back, and we did some diagnosing, and we said, our current platform is just not suitable. And we had 2 choices on where we wanted to go. We said we can either move onto physical infrastructure, or we could look at migrating to a public cloud provider. And the question was really simple, actually. We knew if we went to a physical infrastructure, we'd have to procure hardware first. And if it didn't work out, we've got a load of leftover hardware, which is expensive. So it wasn't really reasonable to move to physical infrastructure if we wanted the risk of failing, because we had no backout for that. And similarly, if we went to physical infrastructure, we knew we'd end up with a bunch of pets, when what we really wanted from this cluster was a lot of cattle. So we made the migration to AWS as a public cloud provider, which unlocked some great potential. So not only did we have much faster hardware, much better hardware, but we were able to spin this up in a day and migrate people across, which is really great. We didn't plan on migrating people across, but we built it, we tested it, and I was like, oh wow, this is amazing, so let's start putting people on it and decommission the old one. And that was great in itself, but running in AWS gave us a few new potentials and new capabilities. So thinking of the theme of resiliency, disaster recovery and all that, we were able to implement Elasticsearch's rack awareness. And this is really great because it means we have complete resiliency of a zone failure in Amazon, which fortunately we've never seen, but we can very simply tag our nodes where they live, and then Elasticsearch will replicate the data into other zones accordingly. So we've got the resiliency if we lose a zone, and we've also got the ability to do 2-stage deploys, which allows much faster and much quicker releases of our Elasticsearch infrastructure. So previously, we'd have to roll a node at a time. That was very slow. Node would go down, it'd come up. We'd have to wait for data to rebalance and rinse and repeat for 18, 20 nodes, and it took hours. But with the rack awareness, we could take out an entire zone, update it, and then do the same with the other. So we cut deploys from about 7 hours to about 30 minutes. So another big win moving to public cloud there. And it was very, very simple to set this up. Again, just a few lines of configuration to get us going. So that's what we had in the end, and that's what we've had for about a year or so. It was working really well for us, except for two main things. The first is how we orchestrated it in the first place. We were using a tool that's now end of life, nobody uses. It was open source, they then took out the open source. So we were sort of in a hotspot where this tool was no longer getting developed, and it wouldn't fit up with the demand of our releases. And then the other one was cost. We built this cluster a year back, we stuck it on some beefy hardware. It worked, job done, we didn't come back to it for a bit. So costs were starting to become quite a bit of an issue. It was very expensive to run. So first off, what we did is we stuck in a Redis queue onto the Logstash side. So we had persisted data, and then we could start scaling our Elasticsearch cluster back a bit, but absorb any pressures. So if we scale back too far, and it can no longer accept the ingest, no longer keep up with demand, we'd have those documents queued. And then likewise, and that was good because we were trying to find the sweet spot of where demand was met, but we weren't overusing hardware and causing very expensive bills. And this was something that worked for us for a few months. It was all right. We managed to scale back a little bit, but costs were still pretty high. So again, we took a step back. And we'd been looking at Kubernetes for a while now, looking to move all our applications over to Kubernetes, leverage the benefits of the open source community and all the vast tooling around Kubernetes. And we made the decision after building a test cluster to move over to Kubernetes and migrate our cluster once more to another cloud provider again. And this has been live for about 3 months now, and it's been really awesome. It's kind of answered some of the concerns we had around Kubernetes, around large data loads, large network throughput, persistent data, all the unanswered questions that we weren't sure about. We've answered with Elasticsearch. It's been a really good sort of test candidate for running on Kubernetes. And out the box, we were able to get some really cool stuff that we hadn't really bothered with before in our cluster. So integration with our single sign-on provider, automatic certificate renewal and generation, all these things that were leveraged from open source tools around Kubernetes that are out the box, really simple to use, and with a few lines of code, essentially, we could get these features, and it's been really good for us. But that wasn't the only thing we did, because that's great and all. We got some new features, but we haven't really reduced our costs yet, which was one of the main factors of moving. So with Elasticsearch, we implemented a hot-warm architecture, so we can carve up our resources more effectively. So we have two sort of node types. We have the hot nodes, which run on fast disks, beefy hardware, and they contain the data that's being written to, the data that is searched most, stuff that is high attention. And then we have the warm nodes, which sort of host old data that's less frequently searched, isn't actually doing any ingest, it's doing a lot less, needs a lot less resource. And we split our cluster up into those two, and then we just sort of migrate accordingly. So at the end of the day, we'll move some data onto the warm nodes, and new data will come on the hot nodes. And that's given us really good performance in search queries, because the search queries on the recent data, where about 80% of our queries take place, are on these hot nodes that have really good hardware, really fast disks. But at the same time, we've not had to increase any cost. And then along with this, with Elasticsearch, obviously your data is replicated naturally. So on the warm nodes, we make use of preemptive instances in Google. So these instances last no longer than 24 hours. They're based on demand. They will be terminated at random points. But since we've built for failure and we have these warm nodes that nothing's changing on them, they're very static, we can afford to lose them throughout the day. One goes down, it comes back up, the data comes back. It's all fine, it's all hunky-dory. And with that, with the preemptible instances, they come at something like an 80% discount when you use them. So if you design anything, not specifically Elasticsearch, but any application to be fault tolerant to nodes dying, then you can start moving some of your infrastructure to preemptible instances, any sort of jobs, and really utilize great savings. So I think our cluster is about 80% cheaper than it was when it was on AWS, and it wasn't very loved. And that's been really good. So the one other thing I wanted to cover was observability of your Elasticsearch infrastructure, and I guess generally any other infrastructure as well. We found in the early days we had no visibility of anything that was going on, and it's really, really hard to diagnose issues when you've got no visibility and you can't see where the problems lie, where the bottlenecks are. So we've got a fairly, not standard, but fairly simple monitoring framework, and we use that to pull absolutely everything out of Elasticsearch. It's got a rich API with a lot of metrics about its internal performance, and we scrape all these out and stick them in Graphite, and then we can monitor on whatever we want accordingly. I didn't want to go into too much about our actual setup, but if you're interested, there's a blog post about our monitoring platform and how it's written, or how it's built, using Sensu. But what I wanted to cover was just a few of the key metrics that really, really helped us out with Elasticsearch, and are things that I'd definitely recommend watching. So first off is Elasticsearch's thread pool. So when you send documents to Elasticsearch, they get put on a queue, and it's this bulk thread queue. And you can monitor this for any backlog in Elasticsearch. If you see this queue building, it's a sign that things aren't ingesting fast enough. And it's really tempting to just say, well, we'll increase the queue, but that's not doing anything for you. That's just giving yourself more time to sort of panic and eventually recover. And then on the same side, you've got the bulk pool rejected. So when that queue eventually fills up, your documents will start getting rejected. And that's not a good thing. Obviously, client libraries will try and retry, but if you're constantly rejecting documents, it's a sign that your cluster's really not keeping up. And you've got to make decisions at this point. Do I add more resources? Do I reduce what I'm sending? Well, this was a key metric that helped us identify our problems in the early days. And if there's one metric you'd want to watch, I'd recommend it be this one. And then the other one is the indices search. So monitoring search performance in Elasticsearch we found to be really difficult. No searches are the same. We don't have control over what people are searching, so we can't optimize specific searches. And it was really difficult to sort of analyze these searches, because once you've done it once, stuff gets cached, it doesn't behave the same again. But Elasticsearch does provide a API to pull out stats about these searches, and you can kind of gain an insight using the stats indices API about how your searches are performing. And you can monitor things like the query versus the fetch. If the fetch is taking longer than the query, it's a good sign that your disks are slow and your disks aren't keeping up. And there's a bunch of other things you can pull from there. And then the last thing is Logstash. So up until recently, Logstash has been a bit of a black box. You didn't really know what was going on. You'd send stuff to it, and it'd send stuff out, but you didn't know internally how well stuff was performing. And if you've got rich data pipelines with a lot of filters, a lot of conditionals, it's hard to identify slowness in your pipeline. But as of Logstash 5, I think it was, they introduced some really rich metrics in their API that allow you to drill into the performance of each individual input, filter, output. So you can really analyze where your pipelines are slow. And you can see if we add a filter, how does that affect performance? Usually it's stuff like GeoIP lookups and rich regular expressions that become quite slow for you. But using this metric, you can make that change that you want to Logstash, monitor the performance. Is it too bad? Is it good? Is it fine? If not, you can back it out. But you can actually no longer, at least we were quite scared originally of making Logstash changes, because we had no visibility of how it was affecting performance. And it's really simple to implement. You just set IDs on all your filters, all your inputs, all your outputs, and then you can scrape them metrics out and stick them in somewhere like Graphite, and you get this really good graphing and tooling. So those are the three things we found to be the most useful when monitoring Elasticsearch. There's hundreds more, and for different use cases, there'll be different metrics that make sense. But the key thing here was just that we needed those metrics when we started, not 6 months down the line. We wasted a lot of time by not having the monitoring up front, the observability of our cluster up front, and that was a big mistake we made. So we've still got loads to do with the cluster, plenty of things we still want to achieve, where we can improve and speed things up, make it better for the consumer. But that's where we are today. It's been about 2 years, and we've made a lot of mistakes and a lot of learnings. Hopefully, people will sort of pick up from some of the stuff and think about how you build it initially and take some of the learnings we've had and apply them earlier on so you don't end up going down the same path we did. So 3 things for my little wrap-up about the 3 biggest things I've learned working with Elasticsearch. Never worked with it before until about a year and a half ago. Was to first understand what you're using Elasticsearch for and what your customers are using it for. It's really hard for us to make changes to how it works and things we think will improve performance when we don't know how customers are using it and we don't know if it's going to impact them and if it's acceptable or not. But if you have a clear outline of how you're using this cluster and you understand how your customers use it, then you can make those changes quickly and without having to sort of go around the business and see if it's going to impact anyone. Second thing was to build it incrementally. When we originally went out and built Elasticsearch, we sort of had this view of how it's going to look in 5 years and how much data we're going to have in there, and we tried to build for that. And in reality, that didn't really work out. When we built for today and tomorrow and a couple of months in advance, we had a lot more success. We could actually sort of get things working today, and if we know we're going to grow down the line, we can address it then. And it also means we kind of keep the experience of Elasticsearch rather than building it once, forgetting about it, and 2 years down the line, having to come back to it and learn it all again. And then the last thing was just to monitor everything at the start. Get your monitoring in place up front. It'll really save you a lot of headaches. An absolute ton of time was wasted because we didn't have monitoring. If you get it up at the start, straight away you can start identifying bottlenecks and where your things are not going right. So those are the 3 big things for our learnings with Elasticsearch. If anyone is interested in asking some questions about how we've built Elasticsearch or has any suggestions on how we can make it better, anything like that, I am available. I'll be around for drinks later, but also at the contact details in the bottom right. But that was it. That was our journey with Elasticsearch. Still going on, but we're proud of where we've got to over the last 2 years. And that's me. Thank you.